A very good morning to everyone present here. A warm welcome to the second day of OSCON 2023. Today we have an amazing few sessions planned for all the participants. I'll be announcing those later. In this plenary session, we have with us a very interesting talk. We have amidst us Dr. M. Rajivan, distinguished professor and former secretary to the Government of India, MOES. I request Dr. T. M. Balakrishnan Nair, co-chair of the Technical Committee OSCON 23 and group director of the Indian National Center for the Ocean Information Services, to please welcome and introduce the speaker.
Good morning, all distinguished dignitaries, scientists, ocean scientists, leaders of oceanography. Before starting my duties, yesterday we have seen the unparalleled achievement of space community on Chandrayaan mission. Let us all appreciate the space community from the ocean community. In the morning, we have also seen the launch of many good products of global importance by the ocean community in India, especially the RSMC on the operational forecasting of ocean forecasting. This is actually first achievement in the world for an oceanography community to give forecasts and other services from WMO, as well as towards stewardship we have seen on DCC, which is also we have inaugurated in the evening. And also we put the combination of wet lab and ocean, wet lab and dry lab in the ocean, two observatories. That is also that kind of thing, the first in the world actually for this. Let us all appreciate the ocean scientists, ocean managers, and the visionaries. I think almost everybody is involved in this. So with this, let me start my duties by introducing the eminent speaker for today's plenary session. Sir, it is my privilege to introduce Dr. Rajivan, former secretary of MOES and a distinguished monsoon scientist. So he's a world-known monsoon scientist. His areas of expertise include monsoon variability, prediction, extreme weather prediction, and cloud radiation. Dr. Rajivan started his career as a senior scientist, scientific assistant in TIFR in 1983. Later, he joined India Meteorological Department as a meteorologist in 1985 and later became director of IMD Pune. His career in IMD lasted for 21 years. From 2008 to 2012, he worked as a senior scientist at National Atmospheric Research Laboratory. Later, he joined MOES in 2012 as scientist G and advisor and continued for 3 years. In 2015, he became the director of IITM Pune. In the same year, he became the secretary, Ministry of Earth Sciences. Now, he is working as MOES distinguished scientist at NSS Trivandrum, Kerala. He has more than 140 research publications of very high impact factor and H index of around 50 and more than 11,500 citations. So he is a fellow of all national academies and he is a member of several academic and research advisory committees. Sir, it is our privilege and we are very fortunate have you are with us with Ocean Community. So I warmly welcome you for this talk. Thank you, sir.
pointer. Thank you. So thank you, Balishtan Nair, and also I should thank Dr. Srinivas and organizers for kindly inviting me for this important event. And I am very happy to come back to Ingois. And I remember this hall as I came along with the Honorable Minister Harshavardhan to inaugurate it, I remember. And my last official visit was to Ingois in March 2020. By that time, COVID came, then I retired in 2021. So I'm coming here after almost 3 years. So thank you, Srinivas, for inviting me, and also happy to meet all ocean scientists here. So I'll be giving a talk on role of oceans on monsoon variability, interannual and decadal. So I'll be talking in a perspective in terms of a meteorologist rather than an ocean scientist, especially from a monsoon angle. This is the monsoon rainfall over India. As all of us know that monsoon rainfall is very important for all of us. And June to September, we have 2 monsoons. One is southwest monsoon, and that is in June to September, and another is northeast monsoon from October to December that basically pertains to southern peninsula. And there's a laser here. Laser here. This one? It's not working.
Laser. Slide change.
Okay. Huh?
This one.
Okay. Let me see. Okay. Yeah, so this is the, I'm not sure it is working. Okay. And so this. It will not show up on the LED. Oh, okay. That's good. That's true. That's true. Okay, fine. And I think the teachers, how the stick is better than this kind of instruments. Okay. And so the right-hand side is basically the interannual variability of Indian monsoon. You can see that there is a large significant interannual variation every year. Each year is different from other years. And the red bars are basically we call drought years, so in which the all India rainfall is less than 10% or so. And green lines are all excess years. There are blue lines are normal years we call. And over that, we have plotted a kind of black line which shows a 31-year running mean, which is nothing but it's a decadal oscillation. So Indian monsoon, summer monsoon exhibits not only interannual variability, also very significant multi-decadal variability, for which I will be talking a little later. Yeah, why monsoon varies from year to year? Assume that there's all ocean surface temperatures doesn't vary any year, and all oceans are fixed at the same sea surface temperatures. Still, monsoon can vary any year. So that is mainly because of internal dynamics, a non-linear internal dynamics. Monsoon still can vary. Solar radiation coming every year. Solar radiation is same almost every year, but still we can expect a kind of internal variability because of the internal dynamics. In addition to that, what I am going to talk is the forcings from different oceans. Oceans can really force monsoon to vary from year to year. And and also snow cover, sea ice, this kind of slowly varying boundary conditions can significantly affect Indian monsoon. And as we know that El Nino Southern Oscillation, it remains as the strongest forcing of the monsoon variability. If we really see the bottom correlation, these are correlation maps with the Indian monsoon with the SSTs. And first one is from 81 to 2022. The last one is from 2002 to 2022, the latest 20 years or so. So you can see the forcing from ENSO, the Pacific, Equatorial Pacific, and also there is influence from IOD, and also the PDO, Pacific Decadal Oscillation in the North Pacific, which resembles like ENSO, and North Atlantic Tripole. So these are the major forcings from different oceans which can influence Indian monsoon. I will come one by one in detail and explain to you. and sorry, and in the multi-decadal way, as I told that we have a multi-decadal variability of Indian monsoon, so that is basically influenced by largely by Atlantic multi-decadal oscillation, which I will talk, AMO, Pacific decadal oscillation, and also North Atlantic tripole mode. And before I talk about the relationships, I thought I will explain very briefly, because a lot of students are there. I am very sure that they will be aware, but still I thought for completion I will talk about. We know this is the El Nino, left hand side is the El Nino feature and right hand side is La Nina. You can see that the large scale ascent in the La Nina years is basically over Indonesia and maritime continent, and this is descending in the East Pacific. The El Nino is just reverses. You can see the reversal in the water circulation, and SST is the El Nino years SST spreads towards East Pacific, and the East La Nina years you have a lot of easterly trade winds, which is not seen, which is there, but it's very weak, very weak trade winds. And also in the ocean bottom of the ocean, you can see the depth of the ocean. You can see that there is a lot of warm water flowing up to East Pacific, which is not seen in the La Nina. So thermocline in the East Pacific is very shallow in La Nina years, whereas in the El Nino years it will be much deeper. And this is the North Atlantic tripole mode. The left-hand side shows the basically a correlation with the NAO. The NAO is nothing but North Atlantic oscillation, which is seen in which is shown in the right-hand side. There are two phases. One is positive NAO, which is associated with a positive SLB sea level pressure over middle latitude North Atlantic, and the polar latitudes it will be cold, so it will be negative. In the negative phase it just reverses. So in the positive phase what happens is the strong pressure gradient from south to north, which is not seen in the negative phase. I think they use some two stations, I don't remember those stations, but they use two stations to find out this index. One is somewhere in the middle latitude and another one is near Iceland. And that forcing will have a forcing on sea surface, ocean surfaces over North Atlantic, and this is the tripole mode we say. And I will come to details of this a little later. And this is the Atlantic, basically it's a kind of a new discovery. We call it the brother of Pacific El Nino, but it's not as strong, as popular as ENSO in El Nino in Pacific. And this is also same kind of structure you can see in the equatorial Atlantic Ocean. There's a warming, and also the winds are getting converged there. Associated with there is a lot of strong strong precipitation in the bottom line. And if you really see the left hand side, it's a Hohmüller diagram which shows that it is more prominent in the summer season, whereas El Nino is completely it's an annual cycle. It starts from somewhere in the pre-monsoon, goes up to peaks up to the November, December, then goes to the next year, few months next year. So there are a lot of papers coming out, very recent papers. Yadav, Sabir Ali, Pota, Pinjar, I think he's from Ingois, he was from Ingois. And so these people have done some work on relating El Nino, Atlantic El Nino to Indian monsoon. I'll come discuss these things later. IOD, we all know, most of you know that IOD, so there's a positive IOD in which the convection will be strong in the West Pacific, West Equatorial Indian Ocean, and suppressed in the East Equatorial Ocean. East Equatorial Indian Ocean, the same negative dipole moment just reverses. But there are plenty of papers giving confusing signals about ideas about IOD, how IOD influences Indian monsoon. Many papers suggest that IODs are influenced by ENSO events, and in El Nino event happens, normally we see an IOD event. But IOD events like 1961, it was not associated with El Nino, but it basically started from local air-sea interaction. So that also is one possibility. And IOD is also considered to influence ENSO, a summer relationship. Indian Ocean plays an important role and how ENSO is going to influence Indian monsoon. And there are studies suggesting that even Indian monsoon circulation can influence the SSTs over Indian Ocean and can really force a IOD to form. Okay. This is a paper taken from Vinay Chandran. You can see that there is a positive IOD in the top. Left-hand side is sea surface temperature and ocean depth at 20 degrees Celsius. And right-hand side is OLR. OLR is outgoing long wave radiation. It's a proxy for atmospheric convection and also the surface winds. And you can see that East Equatorial Ocean positive positive IOD, East Equatorial Ocean, Indian Ocean is suppressed with convection, positive OLR means suppressed convection, whereas in the west is enhanced, blue is enhanced, and also the surface winds are also very strong. You can see that from the East Equatorial Ocean, the winds are getting out, there's an outflow from that region towards Indian region, Indian subcontinent. You can see the negative IOD just reverses. This is the dynamics of ocean IODs and its influence on monsoon. Okay, the next one is PDO. PDO is, you can see the left hand side top is the spatial pattern, which clearly resembles a El Nino kind of things. Spatial pattern is almost similar, only the timeline is much more, and it's 2021 years is the oscillation of PDO, and I'll tell you how PDO is influencing Indian monsoon. And the bottom one is Atlantic multitude decadal oscillation. This is a very famous climate phenomena. It was discovered somewhere in early 90s, and you can see the Atlantic Ocean. It is a large positive SSTs, and if you really see the right hand side is the time series of the AMO. It's about a 60 to 70 year cycle. We have the beautiful negative phase, positive phase, negative phase. Now we are into the positive phase of the AMO, and AMO has a very significant role to play on monsoon variability. Yeah. So this left hand side shows how the correlation with the Indian monsoon with Indian monsoon with El Nino, and you can see that before the monsoon for the current year, if you really take the previous year, correlations are positive, and somewhere it become negative during the monsoon season. You can see it positive is becoming during monsoon season. So it's a kind of a concurrent relationships. In the pre-monsoon season, April, May, June, the correlations are pretty poor, pretty weaker. Okay, it's a concurrent relationship, simultaneous relationship between and so and so. So this was once discussed when in IIT Pune. I remember McFadden was there in that meeting, and he was saying that there could be an influence through warm water volume that is specific, and that can give a kind of an indication even before the monsoon starts. And he shared the data with us, and we wrote the paper. It was published in 2004 or so. And you can see that there is a correlation in the top right hand side is the correlation of warm water volume. And you know the theory of ENSO, it's a simple, one of the simple theories shows that warm water gets accumulated in the West Pacific. It's almost like a bucket of full warm water. When it fills, it just flows out and goes towards east. And so the warm water volume, if you really start monitoring in the Pacific, West Pacific, it can give an indication of how ENSO is developing. And that's why when ENSO monitoring mechanism, if you see the plots, you can see the plots how this warm water is moving towards east. And it can move towards east through MJF mechanism, through Kelvin wave. And when El Nino, we monitor El Nino, we always monitor how the warm water volume is moving towards east. And there is also the right hand side shows the composites of two years. One is drought years, one is flood years. Drought years, you can see that warm water volume will increase, and the flood years, warm water volume is negative anomaly, but it will go on increasing. Negative anomaly will increase. So there is a clear signal, and we use this parameter in our IMD's long range seasonal prediction model as one of the predictors. And but the relationship between El Nino and ENSO and monsoon is not very simple. We know when El Nino happens, when we get the Indian monsoon will be poor. But this is a very interesting paper by Adintam Chakravarti from IISc Bangalore. It's very simple analysis, it is simple statistical analysis. What he says that, so El Nino years can be, previous to El Nino, there can be in the winter season, there can be neutral years, that can be El Nino years followed by another El Nino, and also La Nina followed by El Nino year. This year was El Nino, is a El Nino year, but it is preceded by, last year it was a La Nina. So La Nina followed by a El Nino year. What he says that the results clearly shows that El Nino develops followed by a La Nina will be much more, will have an adverse effect on Indian monsoon than a simple El Nino happening from neutral. For example, El Nino is happening from neutral to El Nino, but the El Nino is happening from La Nina to El Nino are much different. The impact on Indian monsoon is much different. And this is happening in 2023. We are all seeing that La Nina, last year it was La Nina, but it's being followed by, and I'm not able to show that, and you believe me, and you can believe me, I cannot show you with this thing. And you can see that the bottom top all India statistics, and middle one is the El Nino, and the blue lines are the negative departure. You can see all three are departure. That means El Nino year we tend to get the negative departures. But the blue line is El Nino years preceded by a La Nina. So the impact, the negative departure is much, much larger than any other year. And so of course he has given some explanation in terms of pressure gradient, etc. And this is the, again, composites of La Nina to neutral, La Nina to El Nino, La Nina to La Nina. So there can be many phases, and what we are clearly showing is the middle one in the top, which clearly shows when El Nino, La Nina is followed by El Nino, the impact will be, the negative departure will be much, much stronger than any other years. Okay. And Atlantic zonal mode, which I showed a little earlier, will also have a kind of impact on Indian monsoon. And Sabirali's paper very clearly shows that the correlation with the Atlantic mode and Indian monsoon has been strengthening now recent few years. You can take that 74 to 2010, you can see the correlation is much, much stronger. And that is being affected. In the right hand side, it shows the velocity potential outflow in the 200 millibar. You can see the bottom one, which shows very significant influence on Indian monsoon because through the outflow from this Atlantic mode. And it is all strengthening during the recent years. And Equino, this is also well-known kind of phenomena, which Gargill et al. Has written it a few years back. And if you really see the left-hand side shows the SST pattern of OLR with different SSTs, and which clearly shows that the equatorial ocean, you can see there is a dipole kind of thing which resembles Indian Ocean dipole, positive plus and negative here. And the Pacific, you can see another signal from El Nino. And so what did really happen is when the positive IOD happened, the winds will be towards the east. It's easily you can have winds because it flows towards the warm water, and in the negative IOD, the flow will be just reversed. So here, what they have done is they've taken the wind speed at the equator and they try to link it with Indian monsoon thing, and they found that any monsoon extreme, the right-hand side plot with ENSO and Equino, she called it Equino, index on equatorial Indian Ocean, and she said that any extreme of monsoon, whether positive or negative, can be explained either by ENSO or ENSO with Equino. And here, like for example, 1997 was one of the strongest El Nino, but we had good monsoon. We had normal monsoon +2. So it can be explained by adding Equino. So there are many examples which we can quote like that. So what they are saying is El Nino plus Equino can explain all the extremes of Indian monsoon. So I'll go ahead. Yeah, and this is a very interesting paper. They say that this paper very clearly says, last year came, so it very clearly says there are dipole also, there are 3 types of Indian Ocean dipole. Okay, and we take two boxes we take from, one is west and one is east, and we take the difference and it's called DMI or whatever it is. So simply we close the eye and just correlate whatever analysis. What he is saying that the warming in the west equatorial Indian Ocean or cooling in the east equatorial Indian Ocean, how much warming in the west equatorial Indian Ocean or how much cooling in the east equatorial Indian Ocean is very important. Okay, and some years the warming will be almost, so warming and cooling will be of the same magnitude. And what they say that the west, so they made it to 3 types. One is west, where the west equatorial Indian Ocean, the warming will be much more than the cooling in the east equatorial Ocean. And the E type is where the east equatorial Indian Ocean cooling will be much more than the warming or neutral in the west equatorial Indian Ocean. And the C is a kind of a 2 thing, almost very equal magnitudes of anomalies. And it will have different kinds of influence on Indian monsoon. So IOD also, when we talk about relationship, we should also think about what kind of anomalies are there in the West Pacific as well as in the East Equatorial Indian Ocean. But some people, they don't take DMI, it's a difference between two modes. What they more worried about the East Equatorial Indian Ocean, and they take index only from East Equatorial Indian Ocean and try to study the Indian monsoon. Okay, this is Atlantic, so I'll be talking more about Atlantic because Atlantic is becoming more and more important nowadays. This is one of the first papers we wrote in 2008, which shows that there's a beautiful correlations from Atlantic Ocean to Indian monsoon. And here also you can see the kind of a tripole mode. You can see the positive CC and north is negative and bottom also is negative. It's a kind of tripole mode relationship with the Indian monsoon. And also it can be explained in terms of Rossby wave pattern in the middle latitudes. And also in the lower level it can be a kind of gill type of convection and kind of a response in the equatorial ocean, and it can enhance the southwesterly monsoon flow. And this is also one of the parameters which IMD uses for monsoon prediction. And this is a very recent paper, why Atlantic is important. We all know that droughts, all the droughts are not associated with El Nino. For example, 72 was a drought which was associated with El Nino, 87, it's all 2009, 2002, 14, 15. But there are droughts which doesn't happen with El Nino. For example, 2000 plant. Okay, so there are, 74, 79, these are the years where we have droughts, but it's not associated with El Nino. The question is why, okay? And and you can see that in the top, you can see these are the El Nino years in which monsoon was affected. And you can see that it's a lot of it's a typical El Nino phenomena. If you really see the bottom on left-hand side, there's not much warming. This is not a El Nino phenomena, but still we had poor monsoon. That can be explained in terms of, but you see the Atlantic Ocean. You see the Atlantic Ocean and top and bottom. The bottom you can see the large kind of anomalies in the Atlantic Ocean. And so this paper very clearly shows that the Atlantic Ocean, North Atlantic Ocean plays an important role in such kind of years. And that influence is through the middle latitude wave guide. And you can see that beautiful Rossby wave in the top. You can see that negative, positive, negative, positive, negative, positive. So this kind of wave can, and especially in the second half of the monsoon, 1979, if you really see, the second half was too bad, 79. And that was clearly associated with this kind of Rossby wave pattern. And that pattern can really pull the monsoon trough to move north, and also force the monsoon trough to be there so that the break spells are much more elongated, like this year we had in August. And for this, the north middle latitude phenomena with the influence on north middle latitude with Indian monsoon is well known, not much before 2020 paper. Even 1960s, people like Ramaswamy and all used to write paper saying that there is an influence from middle latitude on forcing the monsoon breaks. But this study very clearly shows that Atlantic Ocean plays an important role. This is a very important study. ENSO-monsoon relationships, not only Indian ENSO, if you really take hundreds of years of data and try to correlate monsoon with the different parameters, the correlations are not stable. There is a large secular variation. Some years the correlations are good, some years the correlations are poor. Can I get some water? So some years the correlations are poor, especially when I talk about ENSO monsoon, I should drink water.
There is water.
There is water, thank you. Okay. So the relationships are not very stable. That's why our IMD statistical model have problems in predicting, because they use a fixed number of parameters for calculating regression equation and try to predict it for future. But these relationships can weaken after a few years. So that's why people like Walker and all used to change this, do this kind of review analysis and to show that the secular variation is not affecting the monsoon prediction. This is a very famous paper by Krishna Kumar, 1999, which wrote in Science, which shows that the bottom one very clearly shows the negative correlation has weakened. The relationship between Indian monsoon and ENSO has weakened. It became a very popular paper. Of course, now the plenty of theories have come. Why it has weakened? One is Krishna Kumar told that basically it's a surface temperature over Eurasia that is playing an important role. Somebody talked about ENSO spatial flavors. There are two El Nino flavors now. One is a canonical East Pacific warming. Another is the Central Pacific warming called Modoki or Central Pacific warming. And another is the phase transition from AMO. Another is stochastic perturbation. Somebody from Russia, he told that symbols basically you are a sampling problem. you took some years of data, that sample shows this relationship is weakening. It's a kind of a stochastic process. So there's no physical relationships. There are some people start out the IOD is an important reason, Atlantic SST, so many excuses they told. Now in this scenario, this paper has come said it's not weakening, it is again strengthened last 20 years. And it's very clearly shown. So it's a kind of a light moment I am saying. When things are weakening, immediately write a paper before it starts strengthening again. Okay, when strengthening again you write paper, by that time the weakening will start. So this is a new perspective. It's very, very famous. It's become very popular. Almost 200 citations already came. And it's a kind of journal called the Innovation. So the journals are also finding new ways to write their names. The journal's name is the Innovation. The top one it clearly shows they use different monsoon rainfall. The monsoon the relationship was weakening, as Krishna Kumar told. It's right. But after a few years, you see that after the yellow bar, you can see it's again strengthening. And the second one is basically from Atlantic Ocean, which I will come a little later. And the bottom one, the third one is basically standard deviation. You know, if you really see the formula of correlation, top is the covariance, and bottom one, the denominator is standard deviation of x and y. And this correlation can change if covariance changes, or the standard deviation also changes. If standard deviation is increased for example, your correlation can remain all same. Standard deviation change, but still you can get the different values of correlations. So they say that even the SST kind of a standard deviation also is different. Now, of course, he brought a new idea of how it was strengthening. He says that they identified two events, two modes, two periods, 1979 to 97 and 2000 to 2018. And I'm talking about the bottom one. You can see that it's a kind of a Atlantic SST pattern. It is a regression of topical SST anomalies with the NO3. And the NO3 is nothing but similar to NO 3.4. And you can see that the Atlantic Ocean, please see the Atlantic Ocean. There's a beautiful difference between in the North Atlantic, so Central Atlantic Ocean in the first phase as well as the second phase. The North Atlantic positive phase is good for monsoon. That's what we said, we discussed it. So what the theory says that when the first phase, the North Atlantic phase was favorable, and that was, even though El Nino was trying to influence monsoon adversely, the Atlantic was playing an important role to improve the monsoon performance. Whereas in the second phase, it is not there. So the second phase is again, so this is the two boxes he took, and then he tried to find an index and try to address this issue. And if you really see that top one, you can see the rainfall pattern as well as regression of ISM. You can see that the rainfall is much more weaker in the second phase. And you can see the wind speed, at 850 millibar wind, you can see that it's a large kind of a westerly winds, which clearly shows a weaker monsoon in the northern India. And if you really see the wavelet analysis, the top one is, which clearly shows it was a 4 to 7 year period in the earlier epoch, but now it has become a kind of 2 to 4, a shorter period, much shorter period. And also they found two kinds of El Nino. They told us two kinds of El Nino events are happening. One is a continuing El Nino, and that is in the second figure plot. You can see that the SST, these are basically Hohmüller diagram, and longitude is in the x direction and the months are in the y direction. You can see that the El Ninos are forming much before the monsoon season. It's called continuing El Nino. And in recent years, all El Ninos are called emerging El Nino. It starts somewhere in the March, April of the current season. This is the same thing happened this year, 2023. The warming started somewhere in March, April, May. So they call it, this is an emerging El Nino. And they find that continuing El Nino and emerging El Nino has a different impact on Indian monsoon. And why it happened, it's basically through the influence through North Atlantic SSTs. And this is very clearly shows that the continuing El Nino, how the anomalies in the Atlantic, you can see that, and emerging El Nino. And if you see the difference, the significant difference is seen in the Atlantic Ocean. And when El Nino is continuing, it can have an influence on North Atlantic Ocean, and it can allow the SST, North Atlantic positive SSTs to form. But in the emerging El Nino even, North Atlantic cases, favorable SSTs for Indian monsoon will not be formed because it starts somewhere much weaker, much later. So this is the another, so this can be explained in terms of two simple diagram. Left hand side is 79 to 97, 2003, 2002 and 8. What you can see is a continuing El Nino. It can influence monsoon through water circulation, and you can see the difference in the Atlantic Ocean, a large negative blue anomaly there, and it can influence the monsoon. It can Indian monsoon relationship, and the relationship with Indian monsoon is through gill mode. Whereas in the negative second phase, what we have, the negative anomalies are much weaker, and it will not influence the ENSO-monsoon relationship, but the influence on Indian monsoon is through Rossby wave. The same kind of influence has come from another paper. It's Prasad Pillai from ATM. He also showed that he used one index called North Atlantic mode, AMM, Atlantic meridional mode they call, and this is a difference between two boxes in the SSTs in the two boxes. His observations also very clearly shows that Atlantic is playing an important role on the recent relationship with Indian monsoon and El Nino. How much time I have? Another 10 minutes? Okay. And so if you really see the top one and bottom one, you can see that, I will see here, because I cannot see there. And you can see that the phase in the Atlantic in the first phase is different from second phase, and the corresponding Indian monsoon performance is much different, much different. And rainfall is the bottom and top one is SST. You can see that this is much different. And that can be clearly seen in the right hand side is the omega, vertical velocity over India during positive and negative phases. Again, the mechanism the Atlantic Ocean plays a monsoon through affecting Indian monsoon is through two mechanisms. One is through latitude Rossby wave, another is to the equatorial side, especially from West Africa, Northern Africa. Okay. And this also very clearly shows the same thing. I will not go in detail, which clearly shows the positive phase of AMM is favorable for Indian monsoon, and it can certainly it will give a good monsoon over Africa, and that influence can give an influence on monsoon cross-equatorial flow in Indian monsoon, and also a positive, enhanced monsoon rainfall. So that is the mechanism they are following. Okay. Yeah, so this is IOD, and so we all know that positive IOD is good for monsoon, negative IOD is, this is a very general phenomena, but the relationship is much more than, much complex than what we think about it. And this one paper, Webster-Hoyes, very clearly shows that there is a kind of in the tropical region, there is a biennial oscillation. It's called tropical biennial oscillation. It is different from quasi-biennial oscillation in the stratosphere, which is westerly phase, negative phase. This is the troposphere. So what I can start how it works. These are hypotheses. We need to really put the observation and see. And what it shows that El Nino weaker, the bottom one. Bottom one we can weak Indian monsoon, and Indian monsoon can also lead to positive IOD, and positive IOD can influence strong Pacific trade winds, and it can form a La Nina, and La Nina can form Indian monsoon. Indian monsoon can also affect the negative IOD, and it can form a kind of a weak Pacific trade winds, and again El Nino. So this is a very simplest diagram, and the actual reality is much more complex. But there could be a mechanism involving IOD and Indian monsoon through ENSO in a kind of a biennial oscillation, biennial mode, 2 to 3 year cycle. And if you really take Indian monsoon and do a spectral analysis, you will get a 2 to 3 year peak that you must have seen. And so this can be one of the explanation of that kind of peak which we are seeing. This fellow is saying that not Atlantic, but it is Indian Ocean which is important for the ENSO monsoon strengthening. What they say is it is a very interesting paper again, and which very clearly shows that the first two top two figures you can see, panels you can see. This is El Nino. When El Nino is happening, Indian Ocean also is warming. In those years, Indian monsoon performance will be much weaker, because you can see the wind speed, wind direction is all kind of easterly, which can really affect the monsoon circulation. Whereas when La Nina, and then bottom one you can see that when El Nino is there, but Indian Ocean is cooler, so it can really affect the Indian monsoon performance better. And that can be very clearly seen in the 200 millibar velocity potential in the top. You can, and bottom you can see that when El Nino associated with the warm Indian Ocean can really make a kind of a negative anomaly over Indian Ocean, because there are positive values and the velocity potential basically it means a suppression, and it's basically it means a kind of a suppressed monsoon, whereas the bottom, the suppressed monsoon performance is not very clearly seen. And the bottom right hand side is typical El Nino, La Nina phenomena. So this paper very clearly says that Atlantic Ocean also may be playing a role, but also Indian Ocean as an important component to influence the relationship between ENSO and Indian monsoon. Now, question is, we know ENSO is influencing, but in future what will happen? This is a paper, Vidit Goswami, this is not our BN Goswami, this is a student of IITM, and they have written a paper in just this year, and they say that they used a long 140 years of model simulation, and they found that in the SST 21-year running correlation, you can see that it's all weakening. So what they say that in the future climate warming scenario, the global warming scenario, the climate models very clearly shows the Indian monsoon and ENSO relationship will be weakening. And the possible reason is they say that in the future years positive IOD events will increase. So if you really see the right hand side, bottom right hand side, it very clearly shows the combined probabilities of ENSO and IODs. Left hand side is in the first 70 years, the right hand side is last 70 years. It very clearly shows that the co-probability, combined probability of El Nino and IOD is much more stronger, much more stronger in the last 70 years. So the ENSO monsoon relationship will weaken in future because of the occurrence of more and more positive IOD. That's a good theoretical explanation which they are giving. So we are nothing. Okay, anyway, good. Nothing is there, good. So this is a multi-decadal oscillation, and you can see that beautiful 31-year running moon, you can see that multi-decadal oscillation. And there's a famous paper again by Goswami, BN Goswami. They've done an analysis using IMF. IMF is intrinsic mode function analysis. It's basically that it's a beautiful statistical analysis first discovered in seismology to predict earthquakes, and people are applying it now in meteorology. And so this method, given time series, you can separate it out different modes of different periodicities. And IMF 5, the fifth mode belongs to the multi-decadal variation of 60 to 70 year cycle, and which they regressed that index IMF 5 with the global SST, and the signals are coming from El Nino, another is from Indian Ocean, another is a typical PDO, another is North Pacific. So these are the major 4 forcings which can cause the multi-decadal variation of Indian monsoon. The same results was obtained by Krishnamurthy et al., Krishnamurthy and Krishnamurthy. And so there also they did the multi-channel single spectral analysis. It's also very advanced statistical analysis, which shows the first one is the top one very clearly shows the AMO, Northern Atlantic Ocean, you can say warm water in the Atlantic Ocean. Second one is basically a trend, and third one is a PDO, Pacific decadal oscillation, third one is, last one is tripod. So in this analysis, very clearly 3 major forcings, AMO, PDO, and tripod is playing an important role in Atlantic multi-decadal oscillation. It's very clearly seen in this warm composite of AMO composite left hand side. You can see that the positive composite you get good monsoon, the negative composite you get poor monsoon. The same way warm tripod composite, SST, you can see the difference between the SST in the left hand side and also rainfall over Indian region. So these are the two major modes they say that it plays an important role in the multi-decadal oscillation. And if you really plot the relationship between 31 running mean between Atlantic Ocean, AMO, and Indian monsoon, the red, the orange or whatever red, whatever it is, that is going positive phase. The AMO is gone in the positive phase, but Indian monsoon is not so. So otherwise it was going very hand in hand. You can see that going up, down, going up, going down. So when AMO went, this fellow was not going. Indian monsoon was not going. The question is why? So immediately people will come with the explanation. This one paper by Sandeep. What happened? What happened? Very interesting. Yeah? Oh, some time. Oh, okay, okay. How come? I seen in the morning. Well, maybe it's okay. What do you believe me? I will tell you. Believe me. So this paper very clearly shows AMO monsoon relationship recent years why it is not there, mainly because the Indian Ocean again is becoming warmer, and that is playing an important role in Indian monsoon. As Sandeep is, I think Krishnan also was a part of that team. And okay, the next one also same. So this relation, this paper very clearly shows that, as I told that the positive IOD, positive El Nino is not good for monsoon. Positive PDO is good. But when negative IOD PDO happens, it will, negative PDO is good for monsoon, but positive PDO is not good. So in this year, El Nino was there, but it's a negative PDO. So this paper shows that when El Nino is happening, along with the negative PDO, the relationship will not be much stronger. The negative PDO can really compensate some, not completely, to some kind of helping to Indian monsoon, and the effect of Indian monsoon on, El Nino on Indian monsoon will be much weaker. Congratulations to you. Congratulations to you. I'm talking about something else. Okay, so negative POD, so PDO really plays an important role in when ENSO is happening. This year, El Nino was happening and negative PDO. So we all thought that to some extent, when July was raining very heavily, we thought that it is negative PDO is really helping India monsoon, but looks like it is not so. Okay. PDF. PDF, okay. Oh. We can go back. It will go back. Yeah. Okay. Yeah. So this so this is the paper Goswami which shows that the four regions play an important role, and Krishnamurti says that three important regions. One is AMO, second is PDO, and the third one is North Atlantic Tripole. And so this is the relationship which I told that AMO is not going well with this recent monsoon, with the monsoon with the recent years. And this is the paper by Sandeep et al. Which shows that you can see the different phases of relation on the right hand side. So the Indian Ocean is much warmer than the previous two episodes, two epochs. And this is the negative PDO I said, the relationship with Indian monsoon. You can see the positive PDO, you have good monsoon, negative PDO, you have poor monsoon. Sorry, a positive PDO, you have negative monsoon. Negative PDO, you have good monsoon. El Nino, you have poor monsoon. La Nina, you have poor monsoon. But when it combines together, you can see the last one. Cold PDO with El Nino, and the top one is a warm PDO with El Nino. There's a small difference. And so the cold PDO can really help Indian monsoon from the impact of El Nino. So, but it happens very few years. And so PDO also plays an important role. And this is a very interesting paper last year. It came again emphasizing that again the role of North Atlantic. He talks about AMO, but AMO is a multi-decadal time scale. But he says that even in interannual time scale, Atlantic plays an important role, which I already described with so many papers. And so they are talking in terms of the bottom one is of again Rossby wave pattern. Rossby wave plays an important role in modulating the relationship with Atlantic and Indian monsoon. And he did an analysis. It's very important, very, very beautiful analysis. And I will spend some 2-3 minutes here. Is a relation between cause and effect. You know, in the meteorology, what happens? I mean, there are relationship Indian monsoon, ENSO, but ENSO is influenced by some other factors. But when we connect Indian monsoon with X, Y, Z, but the X, Y, Z are also interconnected. So when you have a relationship, we forget about the relationship between other two factors. In statistics, there is a theory called Granger theory, GRANGER. It's a very famous person. He did an analysis, and then he brought out a kind of a new method to find out in such kind of complex relationship, you can isolate these cross correlations, cross relationships, and identify the unique relationship between all these climate indices. He did exactly the same. The application of Granger theory in meteorology is not very popular, but it is coming up now. And so what they are saying is, I written it right, and maybe I thought I will forget to mention. ENSO drives ISMR negatively, but the AMO drives it positively with the same strength. So what their theory is that the influence of ENSO the relationship of ENSO and Indian monsoon, the same kind of magnitude of relationship exists between AMO and Indian monsoon, but the sign is different. The teleconnection between ENSO and ISMR is simultaneous. Actually, the relations are shown as kind of lines. You can see the lines, red lines and blue lines, and so this is the final explanation. The extratropical AMR and ISMR at a short lag. This is a small lag between the relationships too. And ENSO and ISMR connection both the ways, while the one between AMO and ISMR is one way. The AMI only influence ISMR, whereas ENSO ISMR relationships are both the ways. ISMR also, monsoon also can play an important role on ENSO. And if you read, meteorologists probably know that if you read the old papers in Norman was the DG of IMD, they used to write that whenever Walker used to say that the Walker circulation, the Southern Oscillation Index, etc., is influencing Indian monsoon. El Nino came much later, 1960s it came. And so we have the feeling that ENSO is influencing monsoon. But the relationship is not slave, it's a kind of master and slave. ENSO is master and Indian monsoon is slave. So very clearly, people, even 1950s people used to write articles saying that the relationship is not the master and slave. Later, people like Webster has written long papers saying that these two climate phenomena are basically interactive, selective, they use the word selective. The selective, interactive climate systems. It can influence both the sides. So it's the same kind of inference has come out in this paper. It can play both the roles. And PDO has no direct link with the ISMR. That's the inference they got. And NAO and ISMR association comes through AMO. And Atlantic El Nino, also called Atlantic Nino, also does not have a direct link with the ISMR. Basically, Atlantic Nino is an integral part of AMO, basically. The IOD and ISMR linked directionless connection. There is a relationship, but there is no direction, which is influencing which. The IOD is not a credible driver of ISMR. IOD has a positive directionless association with ENSO, and it has a driving influence on the ENSO. And so final conclusion is basically northern SST is driving the Indian monsoon as equally as ENSO is driving the Indian monsoon. And of course, last 3-4 slides, and but now we know the relationship between all these parameters, the climate forcings on Indian monsoon, and how climate models predict this relationship. This is very important. If we really know the things, it's not sufficient. We need to really predict it, isn't it? So ultimately we need to predict Indian monsoon. So we analyze a few models and see that how good these predictions are, how the relationships are. So this one shows that it's a kind of a North American models in the top one, how the correlations of models with the Indian monsoon rainfall. You can see that, and bottom one is the observation. You can see the El Nino relationship is predicted well in the model, but you can see the strength. The strength is much, much stronger. During the same period of data is used. Observations are not that, the CCs are not, negative CCs are not very strong. But the models observe the relationship is much more weaker, much more stronger. The correlations are much stronger. Some models are even shown minus 0.7, minus 0.75. It's too high. Observation shows only minus 0.4, minus 0.5 or so. And also in the Atlantic Ocean, you should see the observation that we have a tripole mode, which I discussed already, which is not well, to some extent it is reflected in the model, in the top one, you can see that. But you see the Indian Ocean, East Equatorial Indian Ocean and West Equatorial Ocean, there is a kind of dipole relationship, which is not picked up by the model. So models do not do well in the IOD relationship, Indian Ocean relationship. To some extent, Atlantic is fine. ENSO is good, but the relationship is much stronger in the models. And this is seen in, if you really take any model, the story is same. This is how the ASMR correlation, the right-hand side is the ASMR relationship. You can say these are negative correlations. When ENSO happens, monsoon will be weak. But in the model, the relationship is much, much, much stronger, much weaker, much stronger, and you get large negative anomalies. The left-hand side is IOD. The relationship is not picked up by the model. The right-hand side is the North Atlantic SST. There are positive SST, there were observations, positive correlations. But in the model, the whole country is completely of positive correlations. This is again AMO with ISMR, and the right-hand side is IOD. So which very clearly shows the models did not learn any lesson, or do not learn any lesson from these observations. Models have serious problems. And very important analysis which I want to say is that we know the monsoon-ENSO relationship is good, and more in the seasonal prediction model, the most of the skill, how good is the model, comes from this relationship. The top one clearly shows the scatter plot between monsoon prediction skill, and right-hand side is ISMR ENSO correlation. Very clearly shows when the model, when the ISMR correlation is stronger, the skill also is good. Okay, so the models which have better skill in predicting the relationship between ENSO and monsoon will also have a good skill in predicting Indian monsoon. So that's a lesson. But that kind of correlation is not seen in the bottom, you can see with IOD. So IOD doesn't go well with. So the models, the fundamental forcing which influence monsoon is ENSO. And if a model can pick up ENSO signal very well, it can predict monsoon rainfall very well. And I see two more plots which shows that. So whether we can use it for this kind of AMO, multi-decadal oscillation relationship for predicting kind of a decadal prediction, monsoon decadal prediction for next 10 years or so. And this is one paper, Smith et al., which very clearly, they use the CMUP5, the elder version of climate model, which clearly shows that the model is not perfect. It's too good in predicting of temperatures, but not of rainfall. This is the last paper, very recent, it came just last week. We can see that different monsoon season, monsoon regions, and yes, it is written SAS, South Asian summer monsoon. You can see the correlation is much, much weaker when compared to other monsoon season. The multi-decadal prediction for African monsoon is too good. They can really do an operational forecast. But Indian monsoon, decadal prediction is now at present is very, very poor. But we need to really work out because people want to know, especially government, want to know not only next year's monsoon, but also for next 10 years. because they can do a long-term planning in terms of economics, in terms of investments, etc. So everywhere this kind of research is going on, predicting on decadal time scale. Temperature is good, but people want to know about precipitation, especially monsoon. Present scale is not that good. I think with it I will. And last slide is monsoon this 2023. With the known relationship, we know that monsoon, this top one is the rainfall departure on yesterday's thing. You can see they're all red. There are many places the rainfall is deficient. And bottom one is SST anomalies from 1st June. You can see that, El Nino. And also, you can see the Atlantic is favoring. And PDO is favoring. But still, we had poor monsoon. The question is why? You write paper. I will conclude here. Thank you. Any questions I can ask? It's almost 50, almost 50. Unpredictable. So you can, if you develop a model, you can have skill only up to 50%. Remaining, give it to God. Yes, sir. Sinai.
Is able to pick the ENSO, right?
But not all.
Yeah,
Not
almost all.
Almost all.
Yeah.
But again, other parameters also will play in part. How the Indian Ocean is picked up in the model, how the Atlantic Ocean is getting predicted in the model. But if you take 2025 climate models, the correlations are not same for all the models. The models whose correlation is better also the skill is better. There are climate models where the skill is, the ENSO prediction is poor. ENSO relationship is poor.
Correlations depends.
ENSO, it's all. But some of the models are good, not all. The models which we use, for example, monsoon mission model, ECMWF model, NSUB CFS2, so this kind of models are good. But there are many models where the relationship is not good. So those models will perform very poorly. See, in my after doing everything, telling everything, my contention is that ENSO is the strongest forcing of Indian monsoon. If ENSO, El Nino is happening, please be careful. So now El Nino must be saying in a typical filmy style, don't underestimate me. I think I'm sorry, we underestimated.
Yeah.
Dr. Rajivan, thank you for a wonderful lecture. You have given, I think, virtually every aspect of the Indian monsoon and the large-scale connections and the long period connections. Talking about the 2023 monsoon, I read in a paper by Hunt, that British gentleman, that this year, I'm talking about the relatively small scale in time. He says that the increase of rainfall is mainly because of the extension in period of the western disturbances. You have some opinion about
Yeah,
that?
that's true. For example, June rainfall is mainly attributed. June there was no monsoon. It first of all came late, but we still departure was only -10, mainly because it rained very heavily in north, especially Rajasthan. One is the cyclone, the tropical cyclone which formed and moved over Rajasthan, Gujarat. It rained very heavily. And second is the western disturbance, and it rained very heavily in the Himachal Pradesh, and flooding and all happened. If you remove these two spells, June would have been much more weaker, much more poor. The question is why July it rained? That's the question. So now is the monsoon. Another important aspect which I want to mention is monsoon season. When it rains heavily, very heavily. So when rainfall departure, when during rainy season, rainy days, if you really calculate the rainfall departure of all India monsoon, it may be raining only very few places, but the all India rainfall will go up like anything because the amount of rain which is received on it is a small place, it's a small regions. It may be raining only some 4 5 subdivision, but the amount raining was so high, so when I really do all the calculation, it goes up. So when it rains heavily. Then we have a long, prolonged dry spell. So these two extremes of the variability is really playing havoc with the Indian monsoon.
So do you agree that the All India Rainfall Index is somewhat complicated?
Yeah, of
Because
course.
a few stations may give very high, as you were saying just now. And do you agree now with this Hunt's conclusion that the extension of the western disturbances, particularly in the June, July, almost in the monsoon season, is an indication of the climate change or global warming? That's what he said.
No definite answer, but see, climate change is a big basket. If you don't know the answer, you can put it on that. And say that, oh, it is a because of climate change. If you have an answer, you may say, no, it is something else. So, could be. I'm not saying no, it could be. Then we need long-term data and try to analyze it. And Krishnan's, he has worked on western disturbance, and he found an increasing frequency, isn't it? Winter time. Only thing, it is getting prolonged during, see, in the El Nino year, we know that the northward propagation, the northward movement of subtropical will be late, still western disturbance will be active. If you take all the El Nino years, make a composite, you will get a large troughs. So it's a typical El Nino kind of influence. That's what my impression. May not be a signal of climate change.
I will only say in that big basket, India also has a place.
Of course.
Anyway, what I am saying is, I want to make a comment between the observational studies, what people have been doing, and the performance of the models. There's something in between, that is the theoretical study. I will give a paper, a talk given by Professor Adrian Gill. He says, knowledge, understanding, and modeling. I think in our Indian monsoon case, and many other cases also, what is missing is understanding. That is, that all phenomena you have shown, the basic problem I see is the cause and effect. What is cause? What is effect? Sometimes we are confusing between cause and effect.
That's true.
Thank you very much.
That's true. Okay, thank you. Thank you.
Thank you so much, sir, for that very insightful talk. And sir, if you would wait for 2 more minutes. But before that, there is an important announcement. I'll just make the announcement very quickly. The third session of the theme Ocean Observation in situ and Satellite will begin in this same plenary hall at around 11:15 or so. All the students, the participants who have not yet copied the presentation, please make sure that the presentations are copied. You will have volunteers who will help you with the presentation, the copying and everything. Also, the poster evaluation will be between 11:15 to 1 p.m. Yes. So the presenters for the poster, they do not need to be there with the poster throughout the time, but during the lunch time, the break time. Sorry? Okay. I request our director, sir, Dr. T. Srinivas Kumar, and also I request Dr. Shailesh Nayak to please come on stage and felicitate our guest. Dr. Rajivan, sir, thank you so much for that talk. It was absolutely amazing. I'm sure all the participants had a very beautiful time listening to the talk. Thank you. I now request Ashwati Pacha on behalf of the organizing committee to please deliver the vote of thanks.
As we conclude this captivating and insightful plenary talk, I would like to extend my heartfelt thanks to eminent scientist Dr. M. Rajeevan. We are truly grateful for the depth of knowledge shared by you, sir. I also extend my thanks to Dr. T. M. Balakrishnan Nair for his constant support and for also setting the tone of this session. I also wish to express my appreciation to our dear director, Dr. Srinivas Kumar. Thank you, sir. We shall now continue our exchange of ideas and insights over tea. High tea will be served on the ground floor. I invite you all to join us. Before we break, one small announcement to all participants, actually a request. I kindly request you to tag INCOIS on all the social media channels when you're sharing pictures of OSICON. Once again, thank you. Let's continue our engagement during tea.